Hi guys, it's Mrs. Opal here, and welcome to another day of distant learning. Today you are going to learn a new test called the chi-square test for homogeneity. And the big thing here is as you're reading through all your chi-square tests, you want to really tune into what's going on and how many samples you have. So for a chi-square test for goodness of fit, we've had one sample and one variable. For example, we did that hockey players example where we had the one sample was the 80 hockey players, and the one variable was what quarter of the year were they born in, right? Okay. Now we're learning something called a chi-square test for homogeneity. The key here is we have two or more samples in one variable, and we're seeing if that variable is the same or not the same for the two groups. Okay. Here is the problem. Now, you're probably wondering, oh, I want the cutout. I would too. If you have a printer, you could go ahead and print the PDF and cut it out while you're putting it in your notes. Otherwise, you're gonna have to write it down. Pause throughout this. I'm clearly gonna talk faster than I would as I'm teaching because I'm not gonna be walking around. So it's your job to pause, rewind, and then submit anything in the discussion questions online, and you'll see that, and I'll send out a big thing about it, okay? All right, let's go. In a study reported by the Annals of Emergency Medicine in March of 2009, researchers conducted a randomized double-blind clinical trial to compare the effects of ibuprofen and acetaminophen plus codeine as a pain reliever for children recovering from arm fractures. There were many response variables, including the presence of adverse effects such as nausea, dizziness, and drowsiness. Here are the results. Explain why it's important to investigate the question with a randomized double-blind clinical trial. Well, the first thing is you can't establish cause and effect without a well-designed experiment, right? Okay, and part of being a well-defined experiment, designed experiment, excuse me, I'm talking too fast, is you need randomization. And randomization is when you break these groups, all these kids who fractured their arms, when you break them up, you want those groups to look similar and be similar in their makeup. And what do I mean by that? If you have a couple friends who broke their arms, you don't want to like put those friends in that group, right? Necessarily, unless it randomly happens that way. Because then all of a sudden, if all these friends are together, we don't know, are they just feeling better because they're with their friends? Or are they feeling better because the acetaminophen plus codeine is really working, okay? So that is a way to control lurking variables. You want those groups to be similar in makeup. The next thing is that double blind part. That's where the kids don't know what medicine they're getting and the researcher doesn't know what they're getting, right? So that helps control bias as well. Now let's go to the question. Are the differences, it should read, between the two groups statistically significant? So HO is always an is statement. HA is always an is not statement when we're dealing with chi-square. So the first one, we talk about the groups. The distribution effects of pain relief is the same for the ibuprofen and acetaminophen. Now, why did I underline the effects of pain relief? When you're doing a chi-square homogeneity test, this part where I underline, this first part, that's always going to be the variable. That's the one variable we're looking at. And then we always put is the same for the two or more groups that you're looking at here, okay? So let's say it was the distribution of AP scores is the same for this year and last year. I could be looking at that. That would be just an example of something else. And you'll see that in your homework, and I'll help you through that along the way. And then your HA is always is not the same, okay? So we have the distribution of effects of pain relief is not the same. Again, stay consistent with that homogeneity, goodness of fit, and then you're gonna learn independence next. Stay consistent. HO is always is, HA always is not. Now we need to plan. Oh, before we plan, we need our alpha, and our alpha is equal to 0.05. We need to keep it real, guys. We need to keep it real, okay? Now, we are dealing with an experiment. So when we're dealing with an experiment, your R and your I change, right? We say treatments are randomly given, so groups are independent and individual responses are independent. If it was not an experiment, just a friendly reminder, this would be a random sample, okay? If it's not an experiment. Way too big. Hold on here, guys. And then I would be your 10N is less than capital N. And then L is what again? L, we learned that, and if you're gone, it's a large expected value. And that means all of your expected values have to be greater than 5, okay? So let's go through that because it's different now. Our expected values are what should happen with our goodness of fit is what should happen if the null hypothesis is true. And it's similar here, but how do we actually figure that out? So what we do, give me a second, I gotta figure out. Oh, there we go. There's a formula to figure that out. Make sure you get this down. This is very, very important, and I've often seen it in multiple choice released exams. This must be memorized. You take your row total times your column total and divide it by your table total, okay? So what we're gonna do is we need to find the expected counts for this table, okay? And you see here that I have my column totals right here, and right here I have my row totals, okay? So now what I have to do is I have to actually find the expected count by taking a row total times the column total divided by the table total, which is right here. So now I'm gonna go up to the smartboard. We have our row total for adverse effects is 93. We have our column total for ibuprofen is 122. So in order to find the expected count right here, I am going to take 93. So I'll just do the work over here. I'm not going to always show the work. I'll just talk through it. I'm going to take 93, right? That's my row total. Times my column total, 122. I'm going to hit enter, and then I'm going to divide by 234. And I get 48.4872. And I'm going to just go to the nearest 100th. That's okay for your expected counts. Just go to the nearest 100th. So I'm going to do it again now for the acetaminophen plus coding and the adverse effect. So now I'm taking this row total times this column total and dividing it by the table total. So my row total is 93 times 112 divided by 234. And that gives me 44.51. Okay. And we keep doing that, so now we have to do for the adverse effects. We have 141 times 122. Hit enter. Divide by 234. And I have 73.51. And then finally we have 55, okay? Or we need to figure out the expected value for 55. So we say 141 times 112 divided by 234. And that gives me 67.49. And now you can see in our table that all of our expected counts are greater than 5. So we just state that right here for the L. And so we have our conditions, now we're ready for our method. And our method then, and you can simplify that, your method is that chi-square test for homogeneity. Okay, the do part is actually easy now because we know that chi-square statistic. Make sure that you go and become one with that formula sheet. I've shown you where it is. It's either page 3 or page 5, depending on, and I don't have it with me right now, but that's okay. It's either page 3 or page 5, depending on what sheet that I gave you, okay? So, chi-square statistic, let's see if I wrote it down. So now we're on the do part, guys. That chi-square statistic is equal to your observed minus your expected squared divided by your expected. So let's do that now. Chi-square, our observed observed. Our observed for the adverse effects on ibuprofen is 36 minus 48.49 squared divided by 48.49 plus, let's go up again, 57 minus 44.51 squared over 44.51 plus, let's keep going, what do we have next? 86 minus 73.51 squared divided by 73.51 plus 55 minus 67.49 squared divided by 67.49. Now I can calculate that by hand, but I also want to show you how to use the graphing calculator with this. Okay, and everyone's technology can do this. You can calculate this by hand, and then you can use the table to estimate that p-value like I've shown you in class. But let me show you this calculator. So let me get my graphing calculator. It's loading. I'm parched right now. I should not be drinking Diet Coke. I should be drinking water. I realize this, but sometimes you just gotta have that soda. It tastes so good. Okay, so here's how we use our calculator. What we wanna do is we wanna enter our data that we have into a matrix. Let's see if I can move this around. Oh no, that's not good. And I know I can make it split screen, but I don't know how. So maybe someone can email me how to do that. I guess I could Google it too. Okay, so what am I doing right now? I'm hitting second x to the negative first. And that gives me my matrix operators here, okay? And I'm gonna go over and I'm gonna edit, enter, okay? And now I'm gonna enter my data. Now it's important to note, if you look at your data to see how many rows we have and how many columns. I wanna be clear, we never put the totals in as rows or columns. So we have 2 rows and 2 columns. So I'm gonna put a 2 by 2. I'm gonna hit enter, and now I'm gonna enter in the data. I have 36. I am putting in what I observed. Again, I repeat, we're putting in what we observed. Okay, I have 86. Scroll up. I have 57. And I have 55. Okay, and now I have it in my matrix. I'm gonna go to stats. I'm gonna arrow over to tests. I'm gonna go to my chi-squared test. My observed is A, my expected is B. Now I know we found all of our expected by hand, and I did that because you do need to know it for the test. But when you're doing a free response question, the calculator actually will do it for you, okay? Why do we go through that work? Again, you need to know and have it memorized, that row times column, row total times column total divided by the table total. You have to have that memorized. Okay, so I'm gonna hit calculate. And like magic, I'm gonna bring that over. Oops, sorry guys. Set it right here. So now we know what our chi-squared value is, and we also know what our p-value is, okay? And as well as our degrees of freedom. So our p-value, our chi-square ends up being 11.15 with a p-value of 0.0008, okay? And a degrees of freedom of equal to 1. And now we can conclude. Let's write some things over on the do side though. So like I said, I want to be clear here. I don't need to calculate these expected values by hand. Why? Let me show you something on the calculator now. If this was me and I was doing this on a test, I would go ahead and I would enter everything in my calculator and I would run the chi-square test just like we did. And then what I would do next is I would go to my calculator and I would go to second x to the negative 1 and I would hit enter on B and I'd hit enter again. Now you may need to rewind this, you guys, so you can see this. But what these all are right here these are your expected counts. Okay, those are your expected counts. The calculator does this for you when you run the test. That's important to note. So let me repeat the steps that I would do. If it was me on a test, I would not calculate the expected counts by hand. We only did this because it will be a multiple choice question on the test. You need to know how to do it. Instead, if I had to do this, I would do my state, I would do my plan, and then for the do, I would put all of my observed, right, into matrix A, like we just did. I would run the chi-square test and get my chi-squared, my p-value, my degrees of freedom. Then I would go to my matrix editor like we just did and get all of my expected values by hitting enter on matrix B. Okay? Then I need to fill in my work. You must show this work or you will lose credit. Okay? That's such an important piece. That's what I would do. And that's what I have outlined here. Run the test, write the stuff down, okay? Then show your work, okay? Finally, you do need to know the degrees of freedom formula, and you do need to know that for the test. And your degrees of freedom are the numbers of rows minus 1, okay, times the number of columns minus 1. This must be memorized as well, so highlight that. That's got to be memorized. And then finally, you guys are good at concluding. Because our p-value is approximately 0.008, which is less than our alpha of 0.05, we reject the null hypothesis. We have evidence for HA. Now I'm going to just write down the HA. The distribution of effects of pain relief is not the same for ibuprofen and acetaminophen for people like the ones in the study. Why do I have to put that? Because this wasn't an experiment. So we're drawing conclusions for people like the ones in the study. We do this whenever we have an experiment. Oofda, we made it. It's important for you guys to please go through and write down questions you have, put them in the discussion, and I'll do my best to either make videos to get back to you or just write them out to you, okay? You guys have a great day. Stay healthy, stay happy, find things to do to keep you active, get your homework done, and, just keep smiling. If you do want an extra example, here is one. You can pause it right now. I have all my work here, so pause it, go through it, okay? Again, I have my work here. Go through it, and then I'll just show you the key here. I'll just start scrolling up, okay? The key is right here. Oh gosh, you guys, I botched this. I've been teaching too long now. I know you guys have a lot more things to do and you want to wrap up AP here for your notes. The reason I have this example here is to show you, hey, this one is not an experiment. We have separate random samples. We don't have random treatments. So when you have two samples and it's not an experiment, when you're keeping it real, you guys, you got to check it twice, okay? So this one's talking about people who use Facebook, I believe, and we have people on the main campus and then the Commonwealth campus, okay? So random sample of 910 from that main campus, random sample of 627 from that Commonwealth campus. And again, that independence, you need those three. You need to do the 10 times n, right, is less than capital N. 10 times n is less than capital N. And then you have to say the two groups are independent. And this is nothing new to you guys when we've had two samples. Again, I'm coming up on that 20-minute mark. You guys have a great day. And just let me know what questions you have. Signing off.